So as we move into chapter 8, section 4, this has inverse variation and then combined variation. So let's look at this first example. The fan pulley and an alternator pulley are connected by a fan belt on an automobile engine. The fan pulley is 140 centimeters in diameter and the alternator pulley is 80 centimeters in diameter. If the fan pulley turns 440 RPMs, how many revolutions per minute does the faster alternator pulley turn? So one of the things we've learned is the bigger the diameter, the slower the rotation. The smaller the diameter, the faster the rotation. So this is described as inverse variation. So when two quantities vary inversely, one quantity is going to be increasing while the other quantity decreases. So this is not a direct variation problem. This is actually an inverse variation problem. So if I were to increase the manpower for a job, the length of time to complete the job would also decrease. So keep that in mind as well. If you increase manpower, the time to complete the job decreases. So that's another example of inverse variation. So to set up an inverse variation problem, let's first identify the related pairs here. So the fan pulley turns 440 RPMs. So the fan, let's see here. So the fan pulley goes 440 RPMs. Do you know its diameter? The fan pulley was 140 centimeters. So the 140 centimeter pulley and then the alternator pulley was 80. So the alternator pulley was 80 centimeters. So the alternator pulley was 80 centimeters. And it's going to be the faster. It's going to be the faster pulley as well. So we want to know how fast it actually turns. Now, when we do this, the strategy here is we don't go straight across this time. So what we do is, again, notice how the units have to stay on the same side, centimeters to centimeters and RPMs to RPMs. That's a key to start with. But what you can do is the units here cannot appear straight across. So it's going to be like 140 and the 440 is going to be diagonal of it. And then this 80 and this X are going to be diagonal as well. So in other words, notice how the 140 over 80 stays put, but the other side actually gets flipped over to create this inverse relationship. So once we have this proportion set up, that's how we do inverses. We don't go straight across. The relationship actually has to be diagonal of each other. Or in other words, I usually just flip the right-hand side to make that happen. We now can just solve our proportion. Now remember, the shortcut is all you have to do is multiply the diagonals together, and then the remaining number is the number you divide by. That's the quick way of solving a proportion. So that's going to be our relationship. So as we go through this, then we have 440 times 140. We get that answer, and then divide it by 80. And that gives us then 770. And also that it's supposed to be going faster. So 770 RPMs. That's going to be the speed of the alternator pulley. And does that make sense? Well, notice that, if this is 160, this would be twice as big. So that means this would be like twice as fast. So that would be like 880. So notice how if I made that where there's a doubling, if you will, then this should be a doubling as well. Here, this should now be twice as fast. So that should now be 880, if you will. And we're getting 770. So that's that inverse relationship. As you double one, inversely happens over here. The other one actually doubles. So that's a way you can actually do some estimation. And I'm feeling pretty good about that 770 RPMs for the alternating pulley.